This is number 3 on the 2024 AP Pre-Calculus exam, free response question set. And this is one of the sinusoidal model questions. So if you have done the practice problems that they gave on the course description, you would have seen something like this before and gotten practice on it. So no surprises here. Okay, so this says the tire of a car has a radius of 9 inches and a person rolls the tire forward at a constant rate on level ground, as shown in the figure. This is not really helpful, but anyway, point W on the edge of the tire touches the ground at time t equals ½ second. The tire completes a full rotation, and the next time W touches the ground is at time t equals 5/2 seconds. The maximum height of W above the ground is 18 inches. As the tire rolls, the height of W above the ground periodically increases and decreases. The sinusoidal function h models the height of point W above the ground in inches as a function of time t in seconds. Okay, this is part C right now. Let me go back to part 1. Part A. So I did part A and B on one slide because I needed both to do it quickly. But anyway, so part A says the graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. Determine possible coordinates T, H of T for the 5 points. Okay, so how did I get these points is the grand question. The $1,000,000 question in this problem. Okay, so first of all, we know it's sinusoidal, so key characteristics of a sinusoidal curve are the period and the amplitude. So the period is when it starts repeating itself again. So that's what they gave us here. When it reaches the ground the first time, or at one of the times, it's at ½ second. And it does it again at 5/2 seconds, or 2.5 seconds. Okay, so what's the period? We just subtract these two time values, 5/2 minus 1/2, which is 4/2, which is 2. That's the period. So if let's use this reference point, point W touches the ground at t equals ½ second. So if this represents the ground, then J, the t that or the x coordinate, the t coordinate is half. That's how I got this here. And you can just imagine that if the period is 2 seconds and it's half here, then it needs to go +1 to get to P and -1 to get to F. Once again, the period is 2. So between F and P, it takes T equals 2. Okay? J is the halfway point. This is sinusoidal. So J is at the halfway point. And we know that J is half. Or we can say J is half because they tell us that at T equals half, it touches the ground. This is a possible T coordinates of J. Again, it's not a good problem if you see my other video because there's lots of answers that are possible. This is determined possible. So they're probably assuming that you did the easiest one, like I did over here, or easiest per se, because they give you some numbers. But anyway, besides the point, I would love complaining about how they write bad questions on this exam. Anyway, as I was saying, if t equals half here, and the period is 2, and this is the halfway point, so it needs to take 1 second. Is it seconds? Yeah, 1 second to go here. So half plus 1 is 3/2. And then half minus 1 is -½ Okay? I'm assuming they allow negative time. So that's what I put. The scoring guidelines aren't out as of the filming of this video. So I don't know if they would give me credit for this, but this is how I'm thinking through it. This is a valid model, at least. Okay, so that's how I got this, and this, okay? And you could just intuitively think, well, G and K are halfway between F and J and P respectively. So halfway between -½ and ½ that's 0. Halfway between ½ and 3/2, that's 1. So that took care of the T coordinate. Now what about the H of T? The H coordinate, I'll call it. Okay, so they tell us that the radius is 9 and the highest point is 18. So up here, this is where the figure might come in hand, it's 18. Radius is 9, so right at the midpoint, it's 9. Midpoint is here, okay? This is the top, by the way. So F and P would be 18. That's what I did there. And then at the midpoint here, that's where G and K are. That's 18 minus 9. They tell us the radius is 9. So 18 minus 9 is 9. That's here. And then it makes sense that down here, you subtract another 9 because you go down another radius. So that's 0. And that's ground. That kind of makes sense there. Okay, so that's how I got all these points over here. All right, and then the reason why I put B on the same slide is because I need to visualize with the points and with this graph how to model this now. Then I'll ask you to model it as A sine of B times T plus C plus D. Okay, so usually I always take care of the vertical stuff first, because that's usually easier for me. So D represents how much is shifted. If you remember, just transformations in general. This is shifted up by 9 because the average value is 9. So D equals 9. A is the amplitude. So amplitude is how much it goes up and down from the average value, the midline. So it goes up 9 and goes down 9. So the amplitude is 9. So A is 9. Okay, so the trickier part is the horizontal stuff. So B and C. So how did I do it here? Well, how I thought of it is, well, they want us to model it as sine. If it was cosine, we can remember at x is 0, cosine x is 1. So cosine would look like this, exactly, starting from F. Sine starts like from here, actually. Or starting from K, that's totally fine also. So since our J, or when T is 0, or what happens when T is 0, we're at G. So we need to shift the sign, because remember, I just said sine usually starts at this point, or this point, doesn't matter, but since we have K, let's use this point over here, or K is marked, let's use this point. So at T is 0, K should have been there, but it got shifted to the right by how much? Well, we have the coordinates, so that's why I wanted to keep my coordinate points here. It got shifted over by 1. So we can say C is equal to -1. Remember, when it's a minus, it's shifted to the right. Okay, that's why I put C equals -1. Sine starts at K typically. It's my justification. I don't know if you need to even write any of this in the AP Pre-Calc exam to get score, to get full credits, but this is how I thought of it, actually. Okay, now for the period, B, or the frequency, that's how I usually think of it. It's the frequency, the angular frequency more precisely. I don't think you learned that in this class, but usually it's like sine of omega t, where omega, in this case, is B. So B is equal to 2, the period is 2 pi over B. I remember as when it's like sine of omega t, then the period is 2 pi over omega. Okay, in this case, the omega is B. Okay, we know the period. I found it to be 2 up here. So I'll put in 2 as the period. And then I can solve for B. So B is equal to 2 pi over 2, which is pi. So B is equal to pi. Okay, that's how I modeled this guy. And I even confirmed it by graphing it. On this problem, you're not allowed to calculate, but since I'm not taking the exam, I just verified my answer by graphing it, and it matched exactly these points. All right, now we're on part C. This is probably the easiest part of this problem. Refer to the graph of H in part A, so I pasted it here. The t-coordinate of K is T1, and the t-coordinate of P is T2. On the interval T1 to T2, which of the following is true about H? Is it positive or negative? Is it increasing or decreasing? Well, for my model, I made it all positive. So eliminate C and D already. Is it increasing? Is it decreasing? So K to P, clearly it's increasing. I really don't know why they asked such a question. It's way too easy. But anyway, that's that. Describe how the rate of change of H is changing on the interval T1 to T2. Whenever it talks about how the rate of change is changing, that's concavity. In calculus, we call it the second derivative. That's what I was thinking, and second derivative is related to concavity. So what is the concavity of the function from K to P? It is concave down. When it's concave down, that means the rate of change is decreasing. So that's what I wrote there. And that's it for this problem. See, This is very similar to the practice problem in the, I believe, the course description. So if you got good practice on that and fully understood that problem, this is a piece of cake.